Hi guys, welcome to Linear Algebra. We'll be going over section 1.1 in this video. Section 1.1 is basically intro to systems of linear equations. This video might help you with high school linear algebra as well as college linear algebra. Depends on the level that you're studying, but this would help you at any point you take linear algebra. Let's get started. So over here, it shows what a linear equation looks like. So the variables can go from x1 through xn in a linear equation. It can be written as a1 x1 plus a2 x2 up till an xn. And this is equivalent to b. B is basically the answer to the linear equation here. A and B are actually real numbers. They're basically the constants with the variable. So we have a system of linear equations right here. It's basically one or more linear equations involving the same set of variables. So as you can see, the first equation has x1 and x2 with different constants. Same goes for the second one. So in order to solve them, we can use matrix notation. We have to know how to write it in matrix notation. So as a coefficient matrix, we can pick the coefficients that's with the variables. So here we have 2, 3, and 5, and 9. The coefficient matrix does not include the answer vector that goes inside the augmented matrix. So to solve the linear system, we use elementary row operations. We multiply the entire row by the same non-zero constants. We can interchange two rows, or we can replace one row by adding to it a multiple of another row. In order to represent these row operations, I'm going to show you an example real quick. So here we have a question to determine if the following system is consistent. So the first thing that we will do is we'll write it in an augmented matrix. So x1 has the constant 1, x2 has a negative 2, x3 is just positive 1, and the answer is 0. So just to have it easy for you guys for the first time. So in the second equation, we basically have an imaginary 0 x1 here plus x2 since there is no x1. So we just put a 0 here, a 2 for x2, and an 8 for x3, which is equivalent to 8. Same goes for the third equation. This is basically our augmented matrix. Let's do some row operations on it. Remember, these are the only 3 things that you can do when doing row operations. If you do something else, it's going to ruin your augmented matrix and you might end up with a wrong answer. So I'll be demonstrating how you apply these 3 things. So we see that we can cancel out the negative 4 if we times the first row by 4. This is how we will do it. So 4 times row 1 is 4, negative 8, 4, and 0. We would add row 3 to it. So negative 4, 5, 9, and negative 9. We get 0, negative 3, 13, and negative 9. We can basically replace our 3 with this. 1, negative 2, 1, 0, 0, 2, 8, 8. And then the new row 3 that we got is 0, negative 3, 13, and negative 9. Okay, so we see that we do have a 1 for row 1. We do have a 1 for x1 basically. We don't have a 1 for row 2. So how about we try to make this a 1? So we can actually do it since we can see that these are all multiples of 2. So if we divide row 2 by 2, this is what we get. I think I might have missed a negative sign right here. Sorry about that, guys. Alrighty, so we do have a 1 for row 2 as well. How about we try to get it for row 3? So we see that we can cancel out these constants, negative 3, and we can times row 2 by 3, and those would cancel out, equivalent to 0. So let's try that. So 3 times r2 plus r3. Okay, so we got row 3 as 0, 0, 1, 3. We can rewrite this matrix now as this right here. Okay, so let's just write out what this matrix is indicating. So the first row is x1 minus 2x2 plus x3 equals 0, x2 minus 4x3 equals 4. This is what the second row is giving. Since we have a 0 for x1, 1x2 minus 4x3 equals 4. Sorry. And over here we have 0x1, 0x2, and then we have an 1x3. So basically x3 equals 3. Don't forget that this was basically your answer right here. So you have to put the equivalent sign back. So right here we see that x3 equals 3. We can substitute it in equation 2. So equation 2 is x2 minus 4x3 equals 4. X2 minus 4 times 3, since x3 equals 3 times equals 4. So we get x2 equals 16. Let's highlight this. Let's keep this highlighted as well. Now we're looking for x1. Let's plug everything in the first equation. So x1 minus 2x2 plus x3 equals 0. x1 minus 2 times 16 plus 3 equals 0. So x1 equals positive 29. Let's keep this highlighted. Let's recheck if we got it right. Yep. So we basically have an x vector that is basically equivalent to x1, x2, x3. So we know that x1 is equivalent to 29, x2 is equivalent to 16, x3 is 3. So we basically have a solution vector right here. So the question basically asks to determine if the following system is consistent. So we can say that a solution so basically we do see that there is a solution for x1, x2, and x3, which makes the system consistent. So we can just say that there exists a solution for x1, x2, and x3. So the system is consistent. Hope this problem wasn't that bad. Let's do these problems right here, just in case. So it says, solve each system using elementary row operations on the equations or on the augmented matrix. So let's go over the first problem. I think I have it solved. So right here, so we have x1 plus 7x2 equals 4, negative 2x1 minus 9x2 equals 2. So x1 has a 1 right here, x2 has a 7, 7 right here, 4 right here. Then second equation, move to the second row, negative 2 comes here, negative 9x2, and 2 goes here. So we got our augmented matrix right here. So let's do elementary row operations on it. This is our augmented matrix, just like that. So in order to cancel out 1 and negative 2, how about we times the first row by a 2. So 2r1 plus r2. So 2r1 gives us a 2 times 1, 2. 2 7s are 14 and 2 4s are 8. And then we add them. We get 0, 5, and 10. This would be our new row 2. So we replaced it right here. Now we see that this row 2 is basically a multiple of 5. So we could divide it by 5. So divide row 2 by 5 to get 0, 1, 2. Since 5 divided by 5 is 1 and 2 right here. So now, according to this matrix, we have 1x1 plus 7x2 equals 4. This is the first equation. Then we have the second equation as x2 equals 2. So let's substitute x2 into the first equation. So x1 plus 7 times 2 equals 4. So x1 plus 14 equals 4. x1 equals negative 10. So we do have a solution, which is x1 equals negative 10 and x2 equals 2. So this basically says that the system is consistent. Since there exists a solution. Hope this was not that bad. Let's go over another one. So let's quickly go over the augmented matrix. Hope this imaginary line basically helps you remember that we only have x1, x2, and this is basically the answer. So we can write this matrix as 2, 6, negative 6, 0, negative 16, and 32. This row is the R2. You can label it if you'd like. Now we do see that the first row is a multiple of 2. How about we divide it by 2? So this would be 1, 3, negative 3. And we do see that the second row is a multiple of 16. So how about we just keep it positive, keep the first value positive, divided by negative 16. So now this matrix is giving x1 plus 3x2 equals negative 3, and x2 equals negative 2. So the first one, the second one. Let's substitute x2 into x1 in the first equation. So x1 equals 3. Now our answer vector, which is basically x1 and x2, is equivalent to 3 and negative 2. Let's verify our answers real quick. So let's go over the third one right there. So let's write the augmented matrix. You don't have to draw the imaginary line. I'm just drawing it to have you guys understand better, even if you're like in high school or it's like your first time taking linear algebra. I just want to make it easier for you guys. So by now you guys must understand that we can solve it further by doing something like 3r1 plus r2. Okay, so basically we have the same first row. Second row that we got is 0, 0, and 20. So the first row says x1 minus 3x2 equals 4. The second row basically says that 0 equals 20. 0 is basically not equal to 20, as we know, as for fact. So we would say that 0 equals 20 appears in the second row. This is a contradiction, which means the system has no solution. Okay, let's move on to the next one real quick. I feel like this video is getting way too long. Let's just do it here. Let's just do it over here. So let's write it in an augmented matrix. So this is what we're doing right here. So the first row, so we do see that there are two variables, x1 and x2. So the first row does not have an x1, so a 0. It has a 4x2, which is equivalent to 6. Then the second row has 1, -6, and a 3. So let's go back to our row operations. So this says that we can interchange two rows. Let's do it here. Let's implement that. So let's interchange both rows. So okay, now we do see that the second row are multiples of 2. Let's divide it by 2. So now we can say that the first equation that we have from row 1 is x1 minus 6x2 equals 3. The second row is giving 2x2 equals 3. Let's solve for x2, which is a simpler one. So x2 equals 3 halves, so 3 over 2. Let's substitute x2 into the first equation. So x1 minus 6 times 3 over 2 equals 3. Let's just move to a different page. I'm sorry. Let's just add a page. Never mind. So we have x1 minus 6 times 3 halves, or 3 over 2 equals 3. We had x2 equals 3 over 2. So equals 3 plus, how about we, okay, my bad. Let's just simplify. 2 ones are 2, 2 threes are 6. So you could simplify it that way. Or you could even multiply and write it, but this is just simpler. So 6 times 3 is basically 18, and 18 divided by 2 is 9, and there is a negative, so negative 9 technically equals a 3. x1 equals 3 plus 9 equals 12. So you can also write it as or whichever one you like whichever one is asked for. In this case, like, I don't think they asked for it, so it just says solve each system. So we could just provide the solution vector. So we can also say the system is consistent since there is a solution, or there exists a solution. Alrighty, I think this is it for the first section that we're doing in chapter 1. Hope this helped all of you understand row operations better. If there's any question overall, just let me know through the comments and I'll get back to you. And don't forget to watch my next video on section 1.2, which is row reduction and echelon form. I would be explaining in depth and going over questions just like this section. Also, let me know in the comments if there's any other problem that you want me to solve. Alright, thank you guys. Have a great day. Bye bye.